warahmatullahi wabarakatuh, and a good day. Again, we meet in DMM 2633 DRM1413 Manufacturing Technology for Diploma students. I'm Siti Rabiatul Aisyah binti Idris. I will be teaching you for this section and for this subject. And this is for section 1 only, by the way. Okay, now let's look at our content for today. For this one, for this topic, for this lecture, we are going to learn on extrusion, which is metal processing. So in extrusion, we are going to look at on introduction on the extrusion process. I mean, what is extrusion? And then we're going to look at on the process that's covered under extrusion process, which is direct extrusion, indirect extrusion, hot, cold, and process analysis for extrusion. And then we are going also to look at on extrusion dies as well as other metal processing, other types of metal processing. And last but not least, we are going to look at on the defects itself, defects for final product. So as we can see this list here, we know that there are several types of processes covered for metal forming. It's either for metal for bar deformation or for sheet metal working forming. However, for this lecture, we are going to cover on extrusion processes only. So extrusion is actually a compression process. Metal is forced to flow a die opening to produce desired shape. The advantages for extrusion includes we can produce various shape of final product through extrusion, especially hot extrusion because there's heat involved in that, and that'll be easier for us to form the product. Other than that, grain structure and strain properties are enhanced in cold and warm extrusion. Almost a good tolerance because I mean in cold extrusion, so no finishing steps is required. Little or no waste material is produced. The most common material being used for extrusion normally is aluminium. And examples of products include window frame, railway, what rail that the railway, okay, and so on and so forth. Now let's look at the illustration for extrusion process.
The primary type of hot extrusion is direct or forward extrusion. In direct extrusion, the hot billet is loaded into a thick wall container and forced through an extrusion die secured in a holder. The force for extruding is applied by a ram along with an intermediate reusable dummy block. Metal flow from the die is in the same direction as the forward motion of the ram. Since the surface of the billet length slides along the wall of the container, extrusion force depends on the friction between the billet length and the container and the material. The friction portion of the force can be reduced by using lubrication. Force increases rapidly as the billet is upset to fill the container, then increases further as breakthrough force before extrusion begins. Upon breakthrough, the force declines as billet length decreases until a minimum force is reached. As the billet thins, the force rapidly rises again to continue metal flow radially toward the die opening. Resistance to deformation or force requirements increase markedly as the thickness of the butt or unused billet portion decreases. Hot extrusion is most commonly performed on horizontal hydraulic presses. Hot extrusion presses are usually rated in force capacity, which translates to the amount of pressure applied to the billet. That pressure depends on billet material and temper, its cross-section and complexity, length and temperature. extrusion speed, and reduction or extrusion ratio. The extrusion ratio equals the cross-sectional area of the container liner divided by the cross-sectional area of the die openings.
So that's it for extrusion process in general. So just now you've seen the definition of direct and indirect extrusion, as well as hot versus cold extrusion. And now let's look at what is direct extrusion. Um, if you notice from this illustration or this figure here, you can see this is the RAM. Okay, this is the RAM, and this is the die. Okay, basically this is the die. Okay, this is the die. Oh, what is die? Okay. Um, um, so this one is shape of the die itself lah. So now, direct extrusion, also known as forward extrusion. Okay. Later on, you will see the difference between direct and indirect. But before that, let me explain to you what is direct extrusion. And the ram actually compress the material, forcing it to passing through die opening over here and producing the shape or according to the die dimension. So there's a problem in these types of direction whereby a significant friction occurs between work surface and the wall as the billet is forced to slide towards the die opening. Similar things that being introduced, being shown to you through the video just now, and the friction um, can be reduced by using lubrication, for example. And this friction, if we don't overcome it, it will increase. Um, I mean, if the friction increase significantly, then the higher force value is needed to move the ram, Okay. In hot direct extrusion, such problems become even worse because of the existence of oxide layer on the surface of the billet. And this oxide layer may cause defects in final product. So we want to reduce this kind of oxidation. So again, in summary, for direct extrusion, we're gonna need a billet. Billet will be fed into extrusion machine, and this machine will produce or will extrude an extruded product. For example, this one. For direct extrusion, other than a hollow shape of product, we can also produce semi-hollow product. For example, if you can see from figure A and figure B over here. So basically, we can produce any types of shape depending on the die opening. And what will be the difference between direct and indirect extrusion is that if you can look at from this figure here, for direct extrusion, you can see the ram location of the ram is opposite to die location, whereas for indirect, the die is placed on the ram itself. Okay. So once the billet being pushed forward, then it will reverse to the other way around. So this billet will move that way. Okay. Um, um, uh, in an indirect extrusion, the billet will move in linear. Okay. So let's look at in detail what is indirect extrusion. It also known as backward extrusion or reverse extrusion because the die or the billet itself move the other way around once the ram being pushed towards it. The die is mounted to the ram as mentioned earlier, and for these types of extrusion, there's no friction at wall containers, and therefore lower force is used for these types of process. However, there's also limitation for this process, like lower rigidity of hologram and difficult for us to hold the product because it exists to die. Okay, again, different between direct extrusion and indirect extrusion. You can see the illustration over here. Okay, this is the RAM and this one is die. So this one direct extrusion. For indirect, this is the die and this is the RAM. Other than that, the video just now also introduced to you the hot extrusion. The process is the same actually, but the only difference is this at this section, um, temperature temperature being introduced into the process. So that's why they call it as an extrusion. So these types of steps or process also have its own advantages, like it can reduce RAM force because the billet become much more softer. It can increase RAM speed, reduction in grain flow characteristics in the final product. So the product will be much more stronger. Um, what else? However, yeah, lubrication is important in hot extrusion. Glass is sometimes used as lubricant in hot extrusion. And the advantage of using glass as a lubricant is that it can reduce friction. It provides effective thermal insulation between billet and extrusion container. Meanwhile, cold extrusion or cold or warm, actually cold normally refers to a room temperature process. So the advantage of cold extrusion is that no oxidation, high production, cheaper in cost, lower energy, higher in strength due to strain hardening and so on and so forth. Okay, in any types of processes, analysis is became very important because we want to produce a good final product with lesser finishing steps, finishing process. So same goes to in extrusion. Things that is important in this process is include its extrusion ratio or reduction area ratio with the value with this equation r equals to a not divided by af, and then the true strain with this formula. Other than that, we also need to consider the pressure applied to the RAM, over here, because the higher the pressure being given to the billet, then the higher it will passing through the die opening, which actually will affect the final product, our extruded product. And okay, so this is the formula for pressure. Y bar equals to flow stress during deformation. And then we know that during this process, um, friction will occur in it. And therefore, Johnson had proposed an empirical equation to estimate the actual extrusion strain, such as equation over here. Okay, so you can look at the equation with this one is constant value for A and B. Um, So for indirect extrusion, formula for RAM pressure, actual RAM pressure is like this, whereby for direct extrusion, actual RAM pressure is like that. And if we want to consider, okay, before that, first, okay. Other than that, RAM force for direct indirect extrusion is set as here, whereas for power required for extrusion process is P equals to FV. V is actually the velocity of the RAM. Okay, other than that, we need to consider the shape of the die. So whenever involve different types of shape there, we need to apply a K factor shape, or K is known as a shape factor. So in equation just now for indirect extrusion, for example, we just multiply with a K factor. Same goes to direct extrusion, apply with K factor. And the extrusion dies, okay, in extrusion there's also extrusion dies that we need to look at. Die material used for extrusion is tool and alloy steel, for example, normally tool and alloy steel. And the important properties of these die materials should, includes high wear. It should have a high wear resistance. It should have a high hot hardness, high thermal conductivity to remove heat from the process. Meanwhile, for die materials for cold extrusion, normally tool steels and cemented carbides were used. And the properties for those materials are should have wear resistance and ability to retain shape under high stress. Carbides are used when high production rates, long die life, and good dimensional control are required. The other extrusion process that you might want to know is like impact extrusion. So if you look at figure A, B, and C here, it shows the backward, this one backward extrusion, this one forward extrusion. Blank, there's a die over here. This is the die, this is the blank or the raw material, and this is the puncher. Then you start give the force to the raw material or blank there, and it will produce a extruded part there. So this is forward process. Meanwhile, for backward, it is more or less the same as indirect extrusion process just now. Give a punch to the die, to the blank or the raw materials in the die, then it will follow the shape of the punch. After that combination, so the process for impact extrusion can be either backward, forward, or combination of two. For example, products includes toothpaste tube, battery case, and so on and so forth. Other than that, there's also hydrostatic extrusion available in the market. And the process is more or less process is more or less the same as in direct extrusion. However, for this case it used fluid to give pressure to the work billet, and therefore for this one no friction involved in this process. Um, Nonetheless, this process have its own disadvantage. Like, this process requires preparation of starting work billet because we need to have fluid inside working area. Now let's look at the extrusion defects. What are the defects available through this process? Number one is center burst. This one is known as internal crack. It caused by tensile stresses along the center line of the work part during extrusion. And normally this one is very difficult to detect, and if we want to check it, we need to take random sample, then we need to do cross section. And cross section means we have to cut the samples in order to look at the defects inside it. Number two is piping. Formation of sinkhole in the end of the billet. So to avoid such a problem, we just need to add a dummy block with diameter slightly less than that of the billet is used. Other names for these types of defects is tailpipe or fish tailing. And surface defects, this one is commonly occurs due to high after high temperature work or warm work. Warm work seldom occurs, but if during hot working, then this one might be occur if we don't control the speed of the process. Other factors that cause surface cracking is like high friction, surface chilling, or high temperature billets in hot extrusion. Overall, again, this is the extrusion extrusion machine. Yeah, extruder. This is the extruder, can be divided into three sections: fixed section, compression, and metering section. And then there's another part needed for extrusion process, which is the die. Okay, now let's look at the video.
Extrusion is the deformation of either metals or plastics forced under pressure through one or more die openings. The resulting shape is called an extrusion and is produced typically having a constant cross-section profile defined by the shape or geometry of the die opening. With special tooling, stepped or tapered extrusions may also be produced. Almost any thin or thick, hollow, or solid cross-sectional shape may be produced by extrusion. These extrusions are then typically cut to length for use as products, assembly components, or as raw stock for further processing into discrete parts. Extrusions are used for a variety of applications within many industries, including automotive, aerospace, building and construction, furniture, utility conduit, electronics, and many consumer products.
Okay, so that is extrusion in general. Okay, and therefore that will be end for our lecture. And these are the exercises that you might want to do, and you don't have to submit to me by this week or by next week, but you can gather it and just submit at the end of the semester. So that will be all for today. Thank you very much for your kind attention. See you again in the next class. Okay, have fun and bye.